Isaac Newton was born in the mid 17th century, happens to be the same year that Galileo died, and he also happened to be born on Christmas Day. So this guy seems to already just immediately be destined for greatness, if you ask me. But Isaac Newton, unfortunately, in his early years was very, very bullied. In fact, we know the name. I'm pretty sure his bully's name was Arthur. And in his elementary school, he developed sort of a vengeance. He wanted to be better than Arthur and everybody else around him. And that sort of quest for understanding and quest to be better than everybody really powered him to be easily the greatest scientist of all time. That's rarely disputed that Isaac Newton is the greatest scientist, at least the greatest physicist of all time. He's largely self-taught. When he was young, about to go to college, the plague broke out, and he sort of became a recluse. Obviously, there's a plague running around, and studied in his home for years at a time. Largely self-taught during his early years, intensely private and solitary. Yeah, he was a very introverted guy, always working on his stuff in his own house. He developed a ton of theory on optics, and of course, no surprise here, Isaac Newton's main contribution to the world is his invention of calculus. He had a professor in Cambridge named Isaac Barrows, and his professor said that there was some sort of relationship between slopes and areas. He couldn't quite put his hand on it, though, and Isaac Newton, so to speak, took the baton and really took this idea of a relationship between slopes and areas as to its full potential, and through the creation of calculus. This guy's accomplishments and this guy's contribution to mankind is unfathomable, to be honest. Many people put Isaac Newton in the top 5 best human beings to ever live purely because of how much he's done in terms of his inventions, literal inventions, and his discoveries. His invention of calculus, he called derivatives fluxions at the time. It was sort of encouraged or inspired because an astronomer named Edmund Halley wanted to understand this thing called Halley's Comet, and he didn't understand its movement. So he asked Isaac Newton, and Isaac Newton burrowed away in his home for 2 years during the plague and came back with an answer, and the answer involved his invention of calculus. A ton to say about this guy. He was very pious. He was very he's like one of those people that are always like pedantic and correcting you for snivelly things. Perhaps not a crazy amount pleasant to be around, but luckily he had no interest in being around a ton of people. But he did gain sort of prominence, and he happened to be, first of all, he was a professor at Cambridge and a master of the Royal Mint in terms of counting coins and managing England's money, pretty much. And there was a big problem with people cutting coins at the time. They would try to get more money by shaving coins and welding them into more coins, so you can make like 2 coins out of 1 or something like this. And he came up with ways to combat this, of course. He couldn't stop coming up with new stuff. He believed mathematics. He was a very religious person as well. Famously, he did not believe in the Trinity like many of his Christian peers. He thought that he had the backstory of the Bible. He thought he was getting closer and closer to God with his inventions. And you know what? Who's to say he wasn't? But he was very, very religious. He believed in God with his whole heart. In fact, despite the fact that he wrote a ton on calculus and physics, he has much more writing on theology, which has mostly been forgotten because, we think it's all kind of crazy these days what he was saying. But he believed mathematics was a tool to uncover God's orderly design of nature. So, what is his contribution to this week in particular? This week we're defining the integral. And as I said, Isaac Newton noticed something of intimate relationship between his fluxions, his derivative, and the area under the curve. Area under the curve, we had an idea for how to figure that out since Archimedes, really. But he was noticing a really nice relationship between slopes and derivatives. Motivated, though, this was all motivated for him for to have a better understanding of physics. He really had a great. He used a ton of geometry. His notation was not good. He was famously not good with notation, but he was very good with, I guess you would say, theory and concepts. He used mostly geometric and verbal reasoning rather than symbolic notation. He focused on stuff like continuous change and dynamic processes, and he applied his ideas. He was very applied. His whole invention of calculus was so that he can understand things like gravity and, like I said, planetary motion, as he was encouraged to understand orbits through his astronomer colleague, I don't know if he was a colleague, friend, Edmund Halley. So I guess we have Edmund Halley and Isaac Newton's, well, bullying is not good, but Isaac Newton's bully encouraged him to be one of the greatest, perhaps the greatest scientist of all time. All right, so player 2 in this week, probably no surprise, we have Gottfried Wilhelm Leibniz. As Isaac Newton was very, very secluded and introverted, Gottfried Wilhelm Leibniz, this dude with the crazy hair, was kind of the opposite. This guy was very happy to talk to people and talk loudly to people. Here you see him explaining something. Oh, shoot, I think that's the Queen of Sweden? I'm not sure. But he was always sharing his mathematical ideas. Leibniz had no idea what was going on in England. He was a German mathematician. Again, had much more notoriety and popularity. He was a lawyer, a philosopher, a diplomat, a historian, and a mathematician. Certainly, what do you call him? A polyglot? That's not right. That means like you speak a lot of language. Polymath, there you go. He knew all sorts of subjects and could not stop inventing things. As you see here's some of his literal writings, and you see things that we recognize, like the derivative right here. I thought that was kind of cool. And there's famous derivatives that he has listed. And also here is this new thing that I passingly mentioned in class last Saturday, but that is the integral sign. It's an elongated S, which stands for the sum. He's saying that, hey, if we integrate, or if we take the antiderivative, actually, no, what he was doing is finding areas under a curve here. 3 times of x, you'll land at something like x4, x to the 4th power. If you antidifferentiate x twice, notice that there are 2 of these sum signs, you'll get to something along the lines of x cubed. I think this is crazy. This is his actual writing. He's doing calculus that much longer ago. And I also think it's awesome that we're using this same notation. Like the dx is something we've seen before. We call that an infinitesimal. You see his German handwriting right here. And this is an antiderivative. Well, again, he was interpreting this as an area. And due to him and Isaac Newton, they developed an amazing relationship between finding areas and finding derivatives. This is what Leibniz is expanding on right now. And that all comes together in what I call the fundamental theorem of calculus. He was always traveling, very charismatic, as I said, optimistic, systematic, prolific, and diplomatic. He believes mathematics, thanks to him, we do want clear mathematics, should be clear, symbolic, and communicable. So you can tell people, as he's doing here, about the beautiful discoveries he made. So I would say both independently, let me back out here, both Gottfried Wilhelm Leibniz and Sir Isaac Newton independently discovered calculus in the late 1600s. Newton was very dynamic, physics-based in his perspective, and Leibniz was very dynamic, physics-based. Leibniz was much more static, algebraic, and maybe he had a little bit more of a symbolic perspective. Newton really emphasized the meaning behind the mathematics he was discovering, where Leibniz really emphasized the method to get there. Both of these players had a huge part in defining what I call the integral. That's what this week is about. We're going to define it in the next video. Modern integration combines both rigorous accumulation and symbolic computation. And both of these players made great contributions to the invention and the use of the integral.